Good morning, my 8th grade students. Today we're going to talk about solving a system of equations again, but this time by a technique called elimination. So title these notes, Solving by Elimination. Now to even talk about solving by elimination, we need one vocab term. You might already be familiar with it, you might not be. Canceling. So to cancel or canceling can mean two things. One, in addition, it's when we add or subtract to get 0. An example here. Let's say we've got 2x plus 1 equals 1. If we were to subtract 1 from both sides, we could say that those two 1's right there cancel. We could say this one and that one cancel, so we could just cross them out because they'd be 0. And then we'd get 2x equals 0. And really the same thing for the one on the other side as well. Now, it can mean one other thing too, something extremely similar. In multiplication, divide by the coefficient to get a coefficient of 1. So our example of that one, if we said 2x equals 4, and then we were to divide both sides by 2, then we'd say, oh, those 2's right there cancel, meaning they just eliminate the 2. And then we'd get x, or 1x equals 2. Now, I know that we don't usually say 1x because it's redundant. It's the same as saying x equals 2. Even so, you get the idea. All right, now that we've spoken about canceling, put a big section title on this part of the notes and then make 4 lines that we're going to come back to. Title this section Elimination in 4 steps. And like I said, give yourself 4 lines. The reason I'm saying give yourself 4 lines, and we'll come back to it, is because those 4 steps are not going to make any sense until you see an example. So let's show our first example, example 1, of solving by elimination. Let's say I've got 2x plus 4y equals 6. That's my first equation in this system of equations. And my second one is 4x minus 4y equals 12. So let's see. I could potentially graph them, but it would take quite a long time if I weren't using a graphing calculator. I could potentially use substitution, but I'd have to isolate one of these variables, and they're both pretty far from being isolated. So I'm going to use elimination. What elimination effectively means is that I'm going to add these two together in a way that gets rid of one of the variables. So I'm just going to say, all right, I'm going to add these two equations together. Where's my stylus? There it is. And what that'll give me is 2x plus 4x. I also, when you're first doing this, it's handy to make a sort of a chart out of it to divide up the x's and the y's and what they equal. So 2x plus 4x is 6x. And negative 4y, or 4y plus negative 4y right here is 0. So I've got 6x plus 0 right now equals 6 plus 12 is 18. So really, if I follow that reasoning, by adding these two equations together, I got rid of the y's. And I can just say 6x equals 0, equals 18. And now I can divide both sides by 6. And then I'll get x equals 3. So now that's definitely useful because I need to know what x equals to solve my system of equations, but I still need to know what y equals. And really the last step to figure out what y equals is the exact same as substitution. Because I know x, I need to know y. I'm going to plug it into one of these equations. I'm going to use the top one because I think it's easier. So I'll say 2 times 3 minus 4y equals 6. I know that 2 times 3 becomes 6, so I've got 6 minus 4y equals 6. I can subtract 6 from both sides. I'll get negative 4y equals, or I'm sorry, that's positive 4y. Positive 4y equals 6 minus 6 is 0. And finally, I'll divide both sides by 4 and get y equals 0. Because 0 over 4 is still 0. And now I'm pretty much there. I've got my final answer. Final answer 3, 0 in parentheses. That's our first version of solving by elimination. It's pretty much the simplest. Make sure you get this one. Let's see one more that you want to be sure you get. This is the second simplest form. So in our second simplest form of solving by elimination, let's call this example 2, and then put with multiplication. So let's say I've got 4x minus y equals negative 7, and negative 3x plus 2y equals 9. So let's see, what could I add together to get rid of one of them? Well, if I add 4x to 3x, to negative 3x, I'll get 1x, so that doesn't eliminate. If I add negative y to 2y, I'll get 1y, so that doesn't eliminate. None of it eliminates. So what I need to do is find a way to multiply one of these whole equations so that they could eliminate. Thankfully, I know a good way to do that. I'm going to multiply this whole top equation times 2. And actually, wait, before you do that, number both of them. I'm going to number this top one 1 and the bottom one 2. Now, after I multiply the top one times 2, I'm going to get a new equation that I'm going to call 2b. I mean, 1b. Yeah, 1b. 1b is just this new form of my original equation 1. So let's see. 2 times 4x is going to be 8x. 2 times negative y is going to be negative 2y, so that means minus 2y. And 2 times negative 7 is going to be negative 14. And again, I'm going to label this whole equation here 1b, because it's just a different form of equation 1. So let's say step 1, number your equations. Step 2, multiply by a useful number. Actually, let's say by a cancelable number. Step 3, which we're about to see, eliminate a variable. So now I'm going to add equation 2 and equation 1b together, just like I did with the previous one. So I'll get negative 3x plus 8x is 5x. This positive 2y and negative 2y cancel, so that's plus 0, equals 9 plus negative 14 is negative 5. So now I've got 5x plus 0 is just 5x. Negative 5 gets left alone, and I'll get 5x equals negative 5. I'll divide both sides by 5, and I'll get x equals negative 1. And now that brings me to my next step. Step 4. Substitute found variable into one of your 3 equations, because that includes the one that we just made, to find the remaining variable. Alright, so when we do that, if you were to substitute x equals 1 into equation 1, 2, or 3, you'd get that y equals 3. Again, I found that by substituting. I want to keep this as short as I can. So our final answer will be negative 1 and 3. Now you remember how back up here we said elimination in 4 steps? So the first step is one that you might not even have to do. We're going to say, if needed, create a cancelable variable by multiplication. Step 2, combine, meaning add the 2 equations and eliminate the cancelable variable. Step 3, isolate the remaining variable. And finally, step 4 is just substitution again. Substitute the found variable to find the missing one. So that, if needed, create a cancelable variable by multiplication. That's what we did when we turned this equation 1 into equation 1b by multiplying it times 2. Combining them together, that's where we just said, okay, we're going to add the whole thing together from both equations. And that allowed us in the first example to eliminate 4y.